Another episode of Math with Mullins. Today we're going to be looking at lesson 5.5 of the Pythagorean Theorem, and what we're going to be able to do is learn what the Pythagorean Theorem is and be able to find missing side lengths of triangles. First thing we need to know are what are legs and hypotenuses. Legs are the sides touching the right angle, so you have a leg here and a leg here. Notice they're making the right angle. And then we have a hypotenuse that is across from the right angle, so if you look directly across the right angle, this right here is the hypotenuse. This would be a great thing to copy in your notes along with the triangle. And when you're ready to go ahead and click play. The Pythagorean theorem is a formula we're going to use, and it says in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the lengths of the hypotenuse. So what that just means is we can take this formula a squared plus b squared and equal it to c squared. One thing we need to remember, though, is what is each thing. C is always going to be the hypotenuse, so that's something to remember. And then A and B can be the legs. A can be here and B could be here, or you could even switch them around and said A can be down here, B can be here, just as long as C is the hypotenuse, which is directly across from the right angle. Again, take a moment to copy this down in your notes with the theorem or the formula, as well as the drawing with the triangle with A, B, and C located there, and then we'll go on and try a question. All right, here's what we're going to do is we're going to take these questions and we're going to try to find the missing length of the triangles using the Pythagorean theorem. The Pythagorean theorem can always be used with right triangles, so let's go ahead and start with number 1. The first thing we're going to do is write down our formula, a squared plus b squared equals c squared. Before you fill in things, you want to go ahead and give everything a letter. So we're going to say x is a, 29 is going to have to be c since this is the hypotenuse across from the right angle, and 20 can be b. So now I'm going to plug each of those things in. A squared would be x squared plus b squared, that's 20 squared, and c squared is 29 squared. Now we're going to solve for what I can do. I don't know what x squared is yet, so x squared is what I'm solving for. 20 squared is 400, and then 29 squared is 841. Finally, I'm going to try to get x by itself by subtracting 400 from both sides. I'm going to get 441 is equal to x squared. The final step I need to do is I need to find the square root of 441. So I'm going to take 441 and square root it, and I'm going to get x is equal to 21. Okay, so steps are as follows. Write formula. We labeled A, B, and C. We plug in and then solve for variable. Okay, remember the last step would be to find the square root of the number. So let's try that for number 2. Write your formula, a squared plus b squared equals c squared. Let's go ahead and label. We'll say x is a, 24 is b, and 26 would be c, and then fill it in. X squared plus 24 squared equals 26 squared. Next, let's go ahead and square those. I know x squared is still x squared. 24 squared is 576, and 26 squared is 676. Draw my line down the equal sign so I can keep everything separated. Next, I'm going to subtract 576 from 676. I'm going to get a nice 100 is equal to x squared. And then last but not least, to find that answer, I'm going to find the square root of 100. X is equal to 10. Okay? Let's see if you can try these on your own. You're still solving for A for number 3, but it looks like for number 4 you're solving for C. See if you can try those, pause it on your own, and when you're ready, click play. All right, we have x squared, which is A, plus b squared, which is 28 squared, equals c squared, which is 35 squared. Let's go ahead and square these numbers. 28 squared is 784, and 35 squared is 1,225. Next up, I'm going to subtract 784 from my 1,225. I'm going to get 441, common number we saw before. Then my final step is to take that square root of 441, which will give me x as 21. Number 4 is a little bit different because I have my a and b, I don't have my c yet. So as I'm plugging this in, I should be doing 15 squared plus 8 squared equals c squared. Okay? I know 15 squared, that's a part of 1 that we should have memorized by now. It's 225. 8 squared is 64. And let's see what that gets us for c squared. 225 plus 64 gives us 289. Notice they're on the same side, so I add them together. And then to find out what c is, I'm still going to do that final step, which is to find the square root. C is now equal to 17. Again, let's try 5 and 6. You try it first by pausing the video, and when you're ready to check, click play. All right, we've got A, B, and C going on here, so we can say 12 squared plus x squared equals 13 squared. I know 13 squared is 169, x squared is unknown, 12 squared is 144. Next step, subtract 144 from 169 to see how much my leftovers are. 169 minus 144 is going to give me 25. So x squared equaling 25, to find the square root of those, x is equal to 5. And then over here, we can say this is a, b, and c. So I have 12 squared plus 16 squared equals x squared. 12 squared is 144. My 16 squared is another one I should have memorized by now. It's 256 equals whatever that should be. 256 plus 144 is my next step. I'm going to get 400. And then final step, find the square root of 400. X is equal to 20. Oops. Okay. That is going to conclude our notes for today on the Pythagorean theorem. Thanks so much for tuning in. Hopefully this video helped you, and we'll catch you next time.